Video we are going to talk about the deactivating groups. In the previous video we talked about the activating groups. Basically, deactivating groups is the second type of directors, the directing groups. Okay, deactivating groups are basically electron withdrawing groups. In the previous video I talked about the activating groups and they were electron donating groups. These groups are electron withdrawing groups, and they are 3-5 directing. So basically they'll direct the incoming electrophile if the deactivating group is already attached to benzene ring. So the next electrophile that will attack this compound will be directed towards either the third carbon atom or the fifth carbon atom. This 3-5 position is known as the meta position, and therefore they are also known as meta directing groups. Okay, now why are they deactivating? They are deactivating because these groups are electron withdrawing groups. What they'll do is that they'll actually cause the electron density of the benzene ring to move towards themselves. They'll basically attract the electron density towards themselves. They'll withdraw the electron density towards themselves, and as a result, the electron density in the benzene ring will decrease. When the electron density in the benzene ring will decrease, the benzene ring will become less reactive towards incoming electrophiles. A shortcut to identify deactivating groups is that all the deactivating groups will lack lone pairs. They will not have lone pair of electrons. Basically, the atom which is directly attached to the benzene ring will not have lone pairs attached to it. So they will not have um, they will not have lone pairs attached to it. Uh, and the atoms which are directly attached to the benzene ring will either have a partial positive charge or a full positive charge, representing will be present on the atom which is directly bonded to the ring. Some common examples in the past papers which came: the NO2 group, the nitro group, the C double bond O, the ketone group, the carboxylic acid group, the aldehyde group, and CF3 group. All of these are basically deactivating groups. They are 3-5 directing groups. Okay, now let's talk about how they work. The deactivating groups, as I told you guys, have a partial positive or a full positive character or a full positive charge actually. So what happens is that to the positive charge, towards the positive charge, the negatively charged electrons from the benzene ring will get attracted and will start. This group will start pulling the electron density away from the benzene ring. They attract electron density towards themselves, and hence the electron density in the ring, it actually decreases, which makes the benzene ring less reactive towards incoming electrophiles, because the electrophiles are actually attracted towards regions of high electron densities. So when the electron density in the benzene ring will decrease, the incoming electrophiles will be less likely to attack these groups. Now let's look at the displayed structures of these compounds. Basically, the nitro group over here the nitrogen is double bonded to oxygen, whereas it has a dative bond to the other oxygen. As a result, this nitrogen gets a positive charge and the oxygen gets a negative charge. Basically, the atom which is directly bonded to the benzene ring is important. Let's look at the charge. It has a positive charge. So the nitrogen atom has a positive charge. This positive charge attracts the electron density towards itself. When it attracts the electron density towards itself, the benzene ring becomes electron deficient. It actually loses electrons. It actually, yeah, it releases its electron density towards the nitrogen atom. The electron density is pulled by the nitrogen atom, and hence the incoming electrophile. As I told you guys earlier, these groups are 3-5 directing. The incoming electrophile will either get attached to the third position or the fifth position. And basically the reactivity of this compound, overall compound, the benzene ring, the reactivity of the benzene ring actually decreases. So they are called deactivating groups because they decrease the reactivity of benzene ring. The reactivity decreases. The reactivity with the incoming electrophiles decreases. Now, same is the case with the carboxylic acid groups. I've drawn benzoic acid over here. In benzoic acid, the carbon atom is directly bonded to two oxygen atoms, which are both electronegative. So, since they have partial negative charges, the carbon atom over here, which is directly bonded to the benzene ring, has a partial positive charge. This partial positive charge attracts the electron density towards itself, and hence the benzene ring again loses its electron density and becomes less reactive towards incoming electrophile, and the electrophile is most likely to attack the third position or the fifth position. Now let's talk about the aldehyde group. Again, is the same thing. The carbon atom is bonded to the oxygen atom. The oxygen atom has a partial negative charge because it's more electronegative. The carbon atom has a partial positive charge, and this partial positive charge causes the electron density to move towards the carbon atom. And again, the electrophile can only attack the third or the fifth position. And benzene rings, the electron, the reactivity of the benzene ring decreases. And this last compound, this is an important compound, and the carbon atom, again we have a carbon atom, but this time it's not an alkyl group. It's not an alkyl group, it's not an alkyl group, okay. If it were an alkyl group, then it would have definitely activated the benzene ring. But over here, if we look at it carefully, the carbon atom has been directly bonded to the fluorine atoms. Three fluorine atoms, three electronegative fluorine atoms. These fluorine atoms will uh, basically have a partial negative charge. So the carbon atom gets a partial positive charge, and hence this carbon atom, due to the partial positive charge, will attract the electron density away from the benzene ring, and hence will the benzene ring will become less reactive, and hence the electrophile will come and attack the third and fifth position. Okay, guys. So now, after talking, this is all about deactivating groups, and activating groups was covered in the last video. Now, a very important part over here, we've talked about the activating and deactivating groups. We've talked about their examples, but there is an exception to both of them. There is an exception: the halogen groups. The halogen, the group seven, the group seven elements are basically the group 17 according to the modern periodic table. An exception, we have the halogens over here. These halogens are basically an exception to both of them. They are actually 246 directing groups, and the chlorine atom, for example, I've taken chlorine atom as an example. The chlorine atom have three lone pairs. Now, since it has lone pairs, it appears that it should be activating because it would donate the electron, the lone pairs, towards the benzene ring, and they'll get distributed over the benzene ring, forming an extended delocalized pi orbital, and hence will activate the benzene ring. This is according to the concept that we did in the last video, but this is not what happens. They are 246 directing. They are 246 directing, no doubt, because of the lone pairs. They are 246 directing, but they should be activating. But this is not the case. This is the exception. They are mildly deactivating. Okay, so basically the halogens, all the halogens are mildly deactivating. Chlorine is most frequently tested in our exam, so that's why I've given this example. This is mildly deactivating, and it's mildly deactivating because of its high electronegativity. Because of its high electronegativity, it withdraws the electron density away from the benzene ring, and which again decreases the electron density in the benzene ring. So therefore, it deactivates the benzene ring rather than activating it. Well, I've never seen the a question on this before. Like, the examiner has never asked you to explain why the halogens are deactivating. Just remember them as exceptions to the case, and this is important, that they are 246 directing. 246 directing, meaning that the electrophile will come and attack the second position or the fourth position or the sixth position, and they 246 directing, all the 246 directing that we did up there in the previous video, they were activating groups. But the halogens are deactivating, they are mildly deactivating, and reason being the fact that they are highly electronegative, so they actually pull the electron density away from the benzene ring rather than donating it. Now let's compare a few electronegative reactivities. If we compare chlorobenzene with with phenylamine, the phenylamine is more reactive because the amine group activates the benzene ring, and the chlorine, being a halogen, will deactivate the benzene ring. So this is less reactive. This is more reactive. And if we compare phenol with benzoic acid, again phenol will be more reactive because the oxygen group will form an extended delocalized pi orbital and make benzene more electron rich, whereas the carbon atom, being partial positively charged, will deactivate the benzene ring. Okay, guys, so this was a very important video. Thank you so much. Take care and stay tuned.